So it's much better to go for a taper implant if you want to perform immediate loading, of course. Now, what's the effect of bone geometry, implant geometry on the bone healing?
Yes, this I saw yesterday. It took me aback. I was quite surprised.
Really? Of course, most of us think that bone healing is related on implant surface, isn't it?
Right.
Yeah. And this is the case, of course. Most of the healing is related to the chemical properties of the implant surface as well as the geometry, microgeometry, micro level. But also the macrogeometry can make a difference. For example, this study is very striking, showing that osteotome technique to prepare implant site can impair the healing, can reduce the healing, can increase the time needed for the healing. And this is mainly due, according to the authors of this study, to the presence of micro fractures in the trabeculae and bone debris accumulation on the surface, because this bone debris mechanically impair the possibility of the cells to come up to the surface and produce osseointegration, of course. So first of all, osteoclasts should remove all this bone debris, and then the osteogenic cells can come up to the surface and start producing osseointegration.
So it's actually a detrimental process.
Of course, of course.
We all had this original notion that we were compacting the bone and leaving it available.
And this is a mechanical concept very well thought. I mean, mechanically thinking, it's correct. But the biology is not just mechanic. Yes, so you have to also think to the cells as a cell.
That's important information, I think.
I think so, and that's why we are looking at the microscope to understand these things. And what you can see here on this slide on the right side is that if you have rounded threads, the penetration of the rounded threads into the bone causes the formation of many fractures and bone debris accumulation at the interface. And this can reduce the healing and increase the healing time. On the other side, if you use a very sharp threads, the sharp threads can cut the bone, literally, like a knife. And this does not produce breakage of the trabecula. As you can see here, the trabecula are perfectly preserved and does not produce as many debris on the surface as on the other side you can see with rounded shape. Of course, this is not a scientific-based knowledge. We do not have studies comparing these different threads. But we should set up something like this. But in my opinion, this can make a difference in the healing process.
So extrapolating wise, the sharp threads will accelerate the process, accelerate the healing.
At least. Should at least. So the next topic I would like to discuss with you is the bone reaction to the load based on the main body implant design. Because making a different shape of the implant, for example, a taper as compared to the straight wall design, does it make any difference from a biomechanical standpoint transferring the load from the implant to the bone? Of course it does. And this has been shown in simulated models, computer models called finite element analysis that, you know, the engineer they use to build up buildings and bridges, all this kind of stuff where they have to understand what's the effect of load on the structure. They use the same models to understand the effect of the load on the peri-implant bone. And they show definitely that taper implant can have a positive effect in transferring the load as compared to parallel wall cylinders. Again, taper is the winner.
Absolutely. It gives you every reason for using it.
Yeah, of course. So why still?
Why we aren't doing it?
Yes, still having cylinders.
We haven't used cylinders for a long time, but for completely different reasons, just the convenience of tape.
Really?
We didn't understand it totally to this extent. Great.
Also, the thread shapes can make a difference in the transferring the load. And what's the difference between the different threads? Also, this topic has been evaluated in finite element model, computer model simulations. And at this time, what they found, these engineer people, they found is that the square thread seems to play better than others. So instead of having sharp threads, mechanically it seemed better to have a square threads fillet.
And that's different to the round.
Yeah, it's different than the round. So you can have round shape, sharp, or square, or reverse buttress.
Right.
Yeah, many different shapes. And it seems that the square behave better, at least under simulation of the computer models, as well also reducing the pitch and increasing the number of threads. It seems to be better for the transferring the load. So instead of having big thread with large pitch, it seems better to have small threads with
less pitch.
Yes, with less pitch.
Well, just mechanically, you can see they're not going to do as much damage as they go in.
But this is not related to insertion, but to the transferring of load once the mechanical connection of the healing bone is made. Yeah, and you start
same
loading.
For the previous with the square threads.
Yes, exactly. But keep in mind that bone is not a static structure. It's not a computer. Biology reacts to the load, and the bone reacts to the load according to what how the load is transferred, and is able to transform itself and to adapt to the load. As you can see in this histologic picture of implants that were under load for different healing period. This was for 3 months, this was for 6 months, and this has been in the mouth under occlusal loading for 3 years. And these implants were placed into the sinus graft in the upper jaw. And you can consider that the bone density at the time of placement was not very high. It was around 10 to 20% of bone volume. But if you see at this picture, after 3 years, look at how much bone you have around the implant. It seems to be in the mandible. It seems to be a very dense cortical bone. But this is the upper jaw. This is because the bone reacts to the load and is able to manage different type of loading. So clinical stuff showed that not related to the computer simulation, but on the clinical study. This is a literature review of the implants design, thread design, and it seems that effectively square threads actually can behave better, showing a higher percentage of success both in the maxilla and in the mandible in these 3 follow-up studies. Of course, we do not have as many studies as for the standard threads of the Brannemark group, so we need more data, but at least at the beginning it seems to be better.
Exciting.
Yeah. Even if from a surgical standpoint, it's not the ideal thread design for placing implants. So the next one is the neck. The neck of the implant is also very important because it can transfer the loads from the bone to the implant. And at this level, we have the highest concentration of the force. The neck of the implant, the crest of the bone where the neck is placed, is the weaker part of the implant because the most of the force concentrates here. And if we lose this part of the bone because of overloading that can cause bone resorption, it can be at risk. The implant can be at risk. So what's the best design of the implant neck? Because as we know, in the market we have so many different designs.
Multiple different ones.
Yeah. And which is the best one? This study was again done under computer simulation models, and we can see 5 different implants from the market. And the results of the study are striking because they show that type A and C behave better than others. Type A and C we have better than B, D, and E, because they were not overloaded
Right.
at the crest. This means that you can preserve more bone according to the load you gave to the implants. But again, this is just a computer simulation, it's not a reality. We cannot trust completely.
The information.
Yes, this is an information, mechanical information, but we need, of course, clinical study to show that this is true. And the conclusion of this study from the author is that narrowing cross-section at the top of the cortical bone can create more favorable load transfer. And these are the two designs where the connection, yes, of the implant. This is from the what you are using, ankylose implants.
Ankylose,
yes.
right.
And the C is the bicon implant. So we also can have the microthread on the implant neck. Does it make any difference having microthread design? Of course, from the mechanical study and the computer simulation model, it seems that having this kind of threads can increase the ability of the neck to transfer the load to the crestal cortical bone, of course, because you increase the surface, of course. And this implant, these micro threads can engage the bone from the beginning and can also achieve a good integration into the bone at this level. So it could be an advantage. But again, the last word is to clinical studies. And there is, thanks to these authors, we have a study with just 1 year follow-up. But the first year is the most critical, isn't it? Where you can lose bone.
Right.
And this clinical study comparing 3 different implant designs showed definitely that the connection on the neck with the micro threads and the rough surface was the winner. Lose the last amount, the least amount of bone as compared to the other implant geometry of the neck. So, last but not least topic I would like to discuss with you is the connection, the interface. Connection is, as we said at the beginning, is very important for the transferring the load from the prosthetics to the implant, and also because it is a way open to the bacteria from the oral environment to the mouth. And I would like to share with you the results of this study that we just concluded in the last few weeks. This is a dog study where we used full osteotype implants in the mandible of the dogs.
Right.
And we compare in a test and control side straight abutment with a switch abutment design using healing abutments. And we also used 2 types of abutment. One was 1-piece abutment,
Yes.
and the other side we also used 2-piece abutment. So we have 4 groups, straight and switch platform, 1-piece abutment and 2-piece abutments. We let healing for 2 months without loading, of course, and then we did all the morphometric analysis under the microscope. And the striking results is that switching platform does not make any difference if you use a 1-piece abutment.
Right.
You have the same amount of bone loss in the first 2 months, it is 0.6, 0.7 millimeter. But if you use a 2-piece abutment like this, then the switch platform can, of course, be very, very positive as compared to the straight abutment, where we lost 1.6 millimeter in 2 months because of bacterial leakage at the interface that induce inflammatory reaction at the connection interface between implant and abutment, and this caused bone loss. But when we switched the platform, as you can see in these slides, the inflammatory reaction was localized here at the platform.
So it's medialized.
Yes,
it
it's
doesn't
medialized.
decrease it,
Yes.
but it takes it to a different
Yes,
position.
a different position and a different, I would say, spreading. And this preserved the crestal bone, as you can see here in these slides, where
Right.
The bone is preserved in the switch side, but while it is lost in the straight, yes, the straight side.
Which may be beneficial.
Of course,
It may be very beneficial,
Yes.
particularly in adjacent fixtures.
Yes, yes. But the last word is to be said from the randomized controlled clinical trials. And this is a review made from the Cochrane database of systematic reviews in 2007, so it's very recent. Marco Esposito and co-workers did a review of the literature, and they say that there is not yet enough scientific evidence to support the use of one implant design against the other. Not enough studies showing that clinical results are better for one implant system compared to the other. This does not mean that there are not differences.
Right.
We still do not have enough data, but possibly in the future we will have, not now.
But when I look at it, I mean, there is information that, as you've collated your information and everybody else's, that lead you to believe there are certain trends that one needs to follow.
Of course, we have.
And I think that's been very evident.
Yes, but we need some more time to have scientific-based evidence of this. Okay.
You have done a remarkable job.
Thank you very much.
I certainly appreciate, and I'm sure the listeners are going to just love this.
Thank you.
I'll go back. I got a much clearer understanding today than I did yesterday.
Okay, thank you very
Paolo,
much.
thanks so much.
Yeah, you're very welcome.